I recently came across this Melbourne housing sales data on Upwork website. Although I'm not living in Australia, but I'm curious about the housing market there. The data size, it has a decent size, has roughly about 35,000 sales data here. But I don't know how legit it is. I don't know how accurate the data is and how they collect it. So don't use my analysis for your investing decisions. This is just a quick data analysis demo. And I'm just going to use Python to quickly process and explore the data. I'm going to run some data visualizations and a quick machine learning demo. Okay, let's start it. Okay, this is the analysis I just went through on the Jupyter Notebook. First, I imported all the common libraries for the data analysis. Pandas, SPD, NumPy, SMP, and then I load the data. The data header was set as a 0, and all the NA values was marked as a string, as not a number. And I checked the head, first 10 rows, or first 5 rows. And then I checked the shape. It has 21 columns and 34,858 rows. And because the first column is suburbs, so I checked the suburb column. And I noticed there's a couple suburbs only have one sale record here. So those are kind of useless data. And I checked the columns, to get a feeling of the data. There's a couple columns that seems useless for the analysis part, like latitude, longitude, postcode, distance, and then I start data processing. Basically, just clean it up. Like the columns I mentioned above, and the address, seller G, those columns I feel it's not useful for the analysis, at least not useful for the quick analysis. So what I did, I dropped these columns, and save as data frame 1. And then I'm checking any missing values in each columns, and I notice the price has quite a bit missing value there. Since what I'm gonna use, the price, I'm gonna predict the price. The price will be the target column, so we can't really make up any numbers to fill these missing values. So have to drop all those rows with the missing price values. And here's like console areas, region names has only like 3 missing values. We probably can drop all those rows. And for land size, building area, build years, and car space, those we can probably use. I used the mean of land size in each suburb, and I used the mean value of the suburb to fill up those missing values in each suburb. So I checked, how many suburbs there. The unique suburbs, there's a 351. I checked how many number of unique console areas, 33, and the regional name. So got the feeling the region is bigger than the console, and console is bigger than the suburb. So suburb is like a neighborhood. All right, and this step, like I mentioned before, I dropped the price. I dropped the rows with missing price values, and the 3 rows, with having the missing console area values, and the 3 rows with missing regional name values, and so on. So I save as a data frame 2, check, the first 5 rows, it looks okay. And then, the rest missing, the columns with missing values, so it's land size, building area, and year built. I would briefly check the data type here, and I reset the index. And then the steps like I mentioned before, I will need to fill the missing values of the land size, building area, and year built with their mean values of the suburb area, which the property located at, and we calculate the mean value of the building in each suburb, the mean value of the land size in each suburb. Well, in this case, we use the for loop. Get the the unique suburbs names, and we loop through to get the mean values. Well, save us in a dictionary, and then we're gonna read loop through all those dictionaries, and fill all those missing values. These steps are just getting the mean values in each suburbs, and then we're gonna fill all those missing values. So this is filling the missing values of the building areas with the mean values, and here's we fill the missing values of the land size with the mean values of each suburb. And the same thing as here, it's a year built, and we drop the rest, missing values, and then we got a really clean data without any missing values here. So, well, the size has dropped quite a lot, right? And now we have 26,858 records only. And moving on, I'll make a copy of data frame 2, data frame 3, and I made a new column for data frame 3, which is a price per square meter, using the price divided by the building area. And then, well, we notice some servers area only have one property. Like I mentioned before, we from those those columns, like Darley, those neighbors may not be useful for our data analysis. So we basically grouped all those suburbs which only have less than 10 properties. We group them together. Well, there's 64 of them, so we group them together and save them as others. So that's the idea. Moving on, I keep looking for the outliers. So basically, I want to see the areas per bedroom. So I calculated, we used the building areas divided by the number of bedrooms. And I noticed there's some building areas, there's some bedroom areas have less than 10 square meters, which is not normal at all. Like I've never seen a bedroom smaller than 10 square meters. In this case, it could be a typo, or when they entering the data, made the mistakes. So we consider them outliers. We've got removed them. So I did I count how many of them. There's 192 outliers here, and I basically just filtered out like all those 192 outliers and save them as a data frame 4. And then I check the price per square meter static data. The mean looks okay, standard deviation, but the minimum is a little bit extreme, $30 per square meter. I mean, that's kind of low, right? And you can see the maximum and the minimum is far from the mean. So those are outliers. How do I remove them? I basically assume, the price per square meter distribution spread out as a normal distribution. So I calculate the mean and use the mean plus and minus 1 standard deviation, which is covers 68.3% of the data, and we can keep the 68.3% of the data, and the rest will be filtered out. So I made a function called the price per square meter outlier remover, and to remove all those outliers, and I save them as a data frame 5, and this is the result. And then keep looking for the outliers, count, see the unique values of the rooms. Looks good. 2, 3, 1, 4, 5, 6. The bedroom numbers looks good, but the bathroom numbers a little bit off. There's some sales may just have 0 bathrooms, which is not a common sales. I mean, it could be a typo or data entry mistakes. So we've got to filter them out. So what I did, I count them first. There's only 19 of them, and I save as data frame 6 not equal, the bathroom numbers are not equal to 0s. So filter them out, save them as data frame 6. And now we have only 18,501 data records. Next is data exploration and visualization. I import the Seaborn library to make this bar chart. It shows the most houses are sold between 2,500 to 7,500 per square meter range. And X is this time series line chart here. It shows the price per square meters is generally in a slightly downtrend from early 2021 to 2022. Well, this could be a sign of market cooling down, but I'm not sure because recent in early 2020 the price went up slightly. Moving on, the next chart is a joint chart. It's how the price sold versus the price per square meter. In this chart, we can tell most houses were sold in range of 0.5 to 1.5 million price here. And the next chart is similar as the upper chart here. This chart is a hex chart. Sometimes hex is harder to read, and the KDE gives you a cleaner look here, but it's basically tell the same story here. And I count the top 5 suburbs with the most property sales. So these suburbs are the top 5 suburbs with the most property sales, and then I count the top 10 suburbs with the highest average price. Albert Park and Middle Park is the top 1, 2. The next chart is I import the Plotly Express. One thing good about the Plotly chart is you can it's more interactive. You can select and deselect certain areas, and it's It's more interactive, gives you more information. Anyway, this is a box chart, and well, in this chart you can tell this area, Southern metro area, has a wider price spread here. This is maximum, minimum. It's also have a highest median price in this area. Okay, moving on. Next chart is the top 10 suburbs. Albert Park, Meadow Park. It's also the top. Yeah, well, here we calculate the top 10 suburbs with highest average price, right? And this, I want to check the median price. So they, Albert Park and Meadow Park also has the highest median price. But however, here we can see the price spread, right? Like the Meadow Park has a wider spread, and comparing to other suburbs. Next chart is the types of properties. I basically just count, different, sales among the different property, number of sales among the different type of properties. House is definitely still the most popular type of the properties. Townhouse is the least, but it could also means this market has less townhouse supply. But yeah, the townhouse has less sales than the houses. Okay, moving on. This is a bar chart. It shows most of the houses were sold, were built between 1980s and 2000. But this is most recent built houses also sales went up. It could show there's a new supplies get into the market. It gives you an idea about the supply demand in this chart. Okay, next is a box chart I made from Seabourn. Notice the Canterbury, Melbourne, and Brisbane has most houses greater than 200 square per meter sold between 2021 and 2022. Next chart. Well, this chart is really hard to read. We're going to jump over because below we made a similar chart by Plotly instead of Seabourn. It gives you an easier look. Anyway, moving on. This chart it shows the houses has wider spread on price per square meter range, but most of them are in the range of 8K to 12K per square meter. Townhouses has a narrower price spread, and most of them was in the range of 5K to 9K per square meter. And most unit duplex were sold at 4K to 10K range. And next chart. Okay, this chart is the same as this chart, but I made by Plotly Express. And the reason I make that is you can select and deselect certain areas. For example, this Albert Park and Meadow Park has wider spread, and they are at the higher price range here. So if you deselect these two, it will give you a better idea on the rest suburbs. And overall, most properties were sold between 5,000 to 11K per square meters. Properties in the, like I mentioned, in the Mid Park and Albert Park suburbs were clearly outliers because as most of them were sold at a higher price per square meter range. Properties in the Fitzroy, Brisbane, and South Melbourne and Houghton East was sold close to the median price range. No, not the median, to the average price range, which is a 6K to 11K per square meters. Okay, next. Oh, this chart is basically the same as this one. So we're gonna jump over this one and move to the next. This is also the last chart we have here. This is a line chart. It shows the unit and duplex prices has a greater change in the during the market downturns. It could shows this type of property is more vulnerable during the market downturns. It decreased quite sharply in 2021 to 2022, and house prices has the least volatility among the three. It's also most popular type of properties, residential properties, right? And next, we're gonna run a quick machine learning. We're gonna do the future processing first, but we're gonna run a machine learning demo. On feature selections, I dropped the date, method, year, months, and since we're gonna keep a suburb column, and suburb features, suburb is smaller than the console and region area, so I also dropped the console area and region name columns. I kept the type, property type column here. Below, we're gonna use one-hot encoding on suburb and type features. To get one-hot encoding, I use getDummies function, and here I use getDummy functions to do one-hot encoding on these suburbs. I think it's 227 suburbs area, including the other suburbs column we created. And I dropped the other suburbs dummy column just to avoid the dummy variable drag. There will be too many variables, right? And if there will be all zeros on the columns, that means it's the other suburbs. So yeah, just to make things easier for the machine learning part. And I got this. I did the second dummy 2. It's basically another one-hot encodings on property types here. And then put them together. Basically combine the dummy 1, dummy 2, and I made I saved as a data frame 10. Then we move to the model training part. I dropped the column price because this is our target column, and this will save us a Y data frame. And then I did a data split to training and testing data. I use 80 to 20 ratios, 80% of for the training and 20% for testing. So I checked the training data here. I imported a scikit-learn model. In this case, I just want to test it by using the linear regression. The reason I choose linear regression model is because it's a supervised learning. We have the testing and training data here, and the type of variables we are trying to predict is price, right? And the type is continuous variables. So linear regression is a easy pick in this case. So I feed the data here, and then run a linear regression score here. I got the points like 75% correct. It is not a it's a decent number, but I mean the result isn't perfect. Okay. Next is model evaluation. I ran a k-fold. Actually, it's 5-fold, but and a k-fold cross validation here. I import the the shuffle split from scikit-learn model selection, and also the cross validation score here. I pick 5-fold here. It's kind of like standard when I just want to basically test, are there any other rooms to improve this linear regressions. It is the best score we got here. It seems, the score could get as good as 76%, but that's it, right? And this is the five-fold result here. And then I did a grid search. The reason doing a grid search cross-validation is is basically just to pick a better model here. So I'm going to test a lasso and decision tree regression model here. I created a dictionary of model, and with this is the model names, and with parameter options. Those are parameter options. It can add more, but just for demonstration, I picked a few ones, and here I create a function. It's called print research metrics. I basically just want to print out the model name, the best score of that model, the cross validation, and the best parameter set. And I use this for loop to run through each model with different configurations I set up in this dictionary, and this is the result here. Apparently, linear regression has the best score. Well, lasso is slightly lower than the linear regression, but yeah, we're gonna stick with the linear regression model here. I checked the columns I have here, and I created a function called predict price. Basically, we need to put the room number, bedroom number, and bathroom, the number of bathrooms, car, land size, all those variables, and to predict a price by using our linear regression. So I tested out. Assume there's a property with 3 rooms, 3 bedrooms, 2 bathrooms, 1 car, space, 333 land size, 260 building area, and the year built is in 2000, and it's in this suburb. It's a house. The property type is house, and we got the price like this. And also try another set of data here, but notice the number of rooms actually has a greater weight than the carport size. At least on the price predictions, you see I basically decrease the number of rooms and increase the port size, and the result, the prices went down significantly, which means the number of rooms has a greater weight on this model. And now we are running to the last step, is basically the model evaluation part. I want to check the feature importance. So I created this, I use a random for loop, basically check the coefficient of each variables. And some suburbs area, I think these are all the suburb areas. Like for example, this one, they have much higher coefficient than the first 3 or 4, right? So it means the location is big. It has much greater influence on the property value. If you are investor, considering the first factor you need to consider is the location. Where do you want to invest your property? It's a big thing. it may determines the profit value. Yep, that's pretty much everything. Thanks for watching.